Hello, hi. Welcome to today's session. Today's question is, the lifetime of a bulb is exponentially distributed with the mean 100 hours. The bulb remains switched on for exactly 4 hours every day and remains switched off the remaining time. What is the probability that the bulb stops working on or before 25th day? So, in the question, it is given that the lifetime of a bulb is exponentially distributed. That is, it follows an exponential distribution. Let x be the lifetime of a bulb. X denotes the lifetime of a bulb. So, in the question, it is given that x follows exponential distribution. And we need to find out the parameter. Okay, so here it is mean is given as minus 100 hours. Mean is given as 100 hours. So we know that in case of an exponential distribution, that can be written in two forms. One form is that lambda f of x is equal to lambda into e raised to minus lambda x. Okay, the another form can be written as f of x is equal to 1 by lambda into e raised to minus 1 by lambda into x. Okay, so in this case, in the first form, mean is equal to 1 by lambda. And in the second form, mean is equal to lambda. So compare these two forms with the question. So from this question, we can see that mean is 100 hours. So it is in this form. So the probability density function for the given question can be written as x follows exponential distribution of the form f of x is equal to 1 by lambda into e raised to minus 1 by lambda x. Okay, so here mean will be 100 only. So the parameter can be written as x follows exponential distribution with the parameter 1 by 100. Okay, so this is how we can identify based on mean whether the exponential distribution is of this form or whether it is of this form. Okay, so we need to check whether mean, how the mean is expressed, whether it is expressed as 1 by lambda or it is expressed as lambda. So in this question, it is expressed as mean is equal to lambda form. So the corresponding probability density function can be written as f of x is equal to 1 by lambda into e raised to minus 1 by lambda x. Okay. So this is how we identify the exponential distribution. This is the first step. Okay, then what we have asked to find? The bulb remains switched on for exactly 4 hours every day and remains switched off the remaining time. What is the probability that the bulb stops working on or before 25th day? Stops working on or before. So we need to find out probability of x less than or equal to on or before. So less than or equal to 25th day. Stops working less than on or before 25th day. So in mathematical notation, we can denote it as like this. Okay, so 25th day means we need to convert it into hours. So each day it switched on for exactly 4 hours. So 25th day, it that can be written as x less than or equal to 25 into 4. So it will remains switched on for exactly 100 hours. So we need to find out the probability of x less than or equal to 100 hours. Okay. So we can write it as probability of p of x less than or equal to 100. That can be written as 1 minus p of x greater than 100, right? So here it is less than or equal to. That can be written as a complementary probability of 1 minus P of x greater than 100. So in this case, we know that how to find out this probability. That is, that can be written as 1 minus integral 100 into infinity greater than 100. It could be till infinity. So the upper limit is not given. Only the lower limit is given. So we can find it out. 100 integral 100 to infinity 1 by lambda. 1 by 100 into e raised to minus 1 by 100 x dx. Okay, so it can be solved as 1 minus 1 by 100 can be taken outside the integral. 1 by 100 into integral 100 to infinity e raised to minus 1 by 100 x dx. So this is an exponential form that can be integrated as, which is equal to 1 minus 1 by 100 into e raised to minus x is e raised to minus 1 by 100 x divided by, here coefficient of x is minus 1 by 100. So we need to divide it, this function with the coefficient of x, that is minus 1 by 100. So limit has to be given, that is 100 to infinity. Okay. So this can be again written as, which is equal to 1 minus 1 by 100 into e raised to, when we give infinity to x, it will be e raised to minus infinity, it is nothing but 0, minus, when we give 100, it will 100 into 100 will be cancelled out, then only minus 1 will be remaining. So e raised to minus 1. And here it is minus 1 by 100 dividing it with, so it will be minus 100 multiplying it with the minus 100. Okay, it will become 1 minus this 100 and this 100 will cancel out. So it will be 1 minus into minus, it will be plus, then 0 minus e raised to minus 1, it will be minus 1. So this will be minus only. That is that is 1 minus e raised to minus 1. So this is the required probability. So option C is the right answer. So the probability that the bulb stops working on or before the 25th day is 1 minus e raised to minus 1. Thank you.